Welcome to the fourth module of Climate Change and Adaptation course, Earth's climatic system. Here we are going to discuss about cloud, storm, cyclone. Let's begin with the hydrological cycle. We all have studied about that. It's very conventional. We know that how the total water content in the planet is conserved. So there is a evaporations of the water bodies and transpiration of the plants, and this gives rise to the increasing moisture content in the atmosphere in the form of cloud, and which moves and get condensed, and we get rainfall, and part of the rainfall goes to the surface water runoff. That is the rivers and lakes, which represents the surface water, and a part also get infiltrated in the sea, in the ground, which forms the groundwater, and the groundwater also there is a runoff, and finally when they come and meet in the water bodies and mostly in sea, then again evaporation takes place, the cycle gets completed. And the cycle has a smaller component because sometimes the evaporation keeps on taking place in every water bodies, and similarly the precipitation takes place in even water bodies. So this type, the whole hydrological systems sets up such a way that the total water in the planet is maintained, conserved, and available as per the requirements. So let's spend much time into that. Let's see the first phase of that, of the hydrological cycle, that is a cloud formations. So cloud is basically a air mass which is moist and is warm, and which rises along with the air, and it expands in the atmosphere. So what it does actually, whenever this sunlight comes in the water body, immediately the evaporation takes place. But the evaporated water doesn't necessarily become the cloud. It needs some type of particles, which hygroscopic particles, which retain the water. So they are called condensation nuclei. The different particle size of nuclei available, but the most convenient called Atkins size particles. So what happened? These nuclei try to store the water droplets around them, and now this big mass of water droplet is called a cloud. So if you happen to go in aircraft, you can see at sometimes you go above the cloud cover, and previously when people has the opportunity for going by hang gliders or some other country means where they can actually put the hands inside the cloud. In that case, you'll find the droplets of water sticking in the hands. It's just a small droplets of water sustained by this type of particulate matters. So in the sea, the salt contents become nuclei. See, in industrial areas, this soot become nuclei. So just by evaporation itself not become cloud, we need a nuclei to retain them to form the cloud. So here you can say figurative description about how the cloud formation takes place. Now we'll see small animations. How the cloud forms. Cloud. So actually, as you can see, there's tiny drops of water liquid, and it also ice crystals. The cloud formation usually begins when heat from the sun warms the ground. You can see now it is get warmed up and raise above the ground level, and when that gets cooled, then tiny droplets, as I mentioned, condensation nuclei or aerosols, around that the droplets become condensed, and that's how water comes. And this nuclei is very small in size, and the droplets are very small. You see that 100 millions of them are present in one cloud, and if you weigh all of them, it equal to almost 100 elephants in all the cloud coverage in the world. But they are very tiny and spread out. Sometimes they give the larger droplets and they merge together this way, and when size becomes bigger, it cannot sustain it becomes rainfall. This is how rainfall takes place. I mean cloud and which transfers back to rainfall. Then how does this condensation takes place then? There are different ways. It can be orographic. Orographic means they lifted by, so when the cloud mass or air mass, which is from the cloud, which goes and hits against a mountain range. So what happens? It cannot penetrate the mountain, of course. So it will be raised upwards. So as it goes upwards, as you know by lapse rate, as you go upwards, the temperature profile shows that reduction in temperature with height. So gradually being further chilled, and so that water droplets which are unsaturated at lower temperature become saturated at higher temperature. So rainfall takes place. For example, if you take some cold drinks, if you see the cold drinks, if you drink it when it's chilled in the refrigerator, it appears much more sweet. But when it is normal temperature, or for them to be warm, sweetness reduces. Why? So the sugar content inside the cold drinks you are using is actually saturated at low temperature when chilled it. And when heat it up, the temperature increases, then becomes unsaturated. You all know that. In water, if you heat it up, more and more salt will be used for saturating that. Less temperature, same salt will be saturated. Similarly, at lower temperature, the droplets will be, the cloud is saturated. So naturally, rainfall takes place. That is orography. Convectional uplifting, which is basically because of this convection current sets off. Then ground becomes warmer up and it lifts this air mass on the top and cloud, and because of that, when it goes upwards and becomes chilled, because same profile here, mountain region here by itself, the air pressure itself pushes it off, so we can chill, again rainfall take place. Frontal rainfall is a little different type, where what happens that when cold air mass and hot air mass or the cloud comes in contact with the cold regions, so what, and the boundary, the front of that, they become condensed, because low temperature again become saturated with the water content. So rainfall takes place. And there is another type of condensation, this radiative cooling, that is because of the difference in, and during night time our planet gives back the heat, so we can chill. So because of that also some water condensation takes place, but that is not in big rainfall. Mostly the fog we see is because of radiative cooling. So therefore different mechanisms by which we can get rainfall, condensation of that. So what are the, and you can see the different types of clouds are there. And I have classified the different clouds with high level clouds, medium clouds, based on altitudes, and low clouds. And there are some clouds of vertical growth. We have seen that like a column the cloud is growing. And some are unusual clouds for different situations and different mechanisms formation. Contrails is another type of clouds, specialized clouds. And I have given the depth and the height, altitudinal height by which they occur. And out of them, the most common clouds are cirrus clouds, which is like a white, fleeky type of cloud, which doesn't give rainfall. You can see that flat type. And cyclone, it is like mostly aircraft when crossing over the ocean. You can see that how like a big cotton balls this keep on moving. This comes under the cyclone. Altocumulus, this is similar to that, but they rise in the higher altitudes. Altostratus, again higher altitudes, but it is more layered like. Stratus is like layers, and it's cover a wider range of the atmosphere. And then we go about to cumulus, and these are the stratocumulus and cumulus. These are the ones which mostly give the rains to us, because in fact cumulonimbus is the clouds, black clouds which gives the rain. Okay, so now the cloud formation and monsoon rainfalls does vary throughout the year. Why? Because intertropical convergence zone we discussed in previous module, it keeps changing as per the summer and winter. It goes towards the north of the equator, during summer time, and toward the south of the equator in winter time. So due to this, the variations in that, so naturally the cloud formation and monsoon rains does change. And you can see a small animations. How does it take place? Now you can see how the Hadley cycle, which is the main cause of the rainfall in tropical regions, how it from different months. So during the winter time, it goes toward the extended more toward the south, and sometimes become double cells, and then again during in summer time it becomes more expanded and more focused on northern sides. So you can see the variations are changing. Now, so any variation in that can lead to storms and hurricanes, when wind pattern become much more stronger than the normally expected for the basic hydrological cycle maintenance of the water balances. So it becomes storms and hurricane. What are they? So they belong to a specific category called tropical cyclone, the generic terms used by meteorologists. So here is a system of clouds and thunderstorms that mostly tropical, subtropical water, and which is very low level circulation, low height circulations. And when the wind speed reaches up to around 39 miles per hour, in that case called tropical storm. Tropical depression is a generic categories. Any depression means what? Depressions means low pressure, low air pressure, so that wind will become the cold wind coming from surroundings. So the depressions increased, and where the speed of the air from outside, from surroundings, in more than 39 miles per hour, in that case they become, this is called tropical storm. And when it increases further, it reaches up to 74 miles per hour, that become hurricane, typhoon or tropical cyclone, depending upon where it originates. If in North America, North Atlantic or Northern Pacific, you look at the Pacific Oceans, the eastern side of the Pacific Ocean will be towards the America, although the America is western side of India. But when you look at the Pacific Ocean perspective, then it looks to be eastern side, as you can, is a globe. So the North Atlantic and central North Pacific, eastern North Pacific, northeast Pacific, and these are areas where hurricane term is used. You can see that in this map on the right side. You are seeing the hurricanes. These are the locations where hurricanes are there, mostly Pacific zones. And the same type of disturbances in Northwest Pacific, Northwest, that means it refers to Asia, that is called typhoon. Meanwhile, the South Pacific and Indian Oceans, South Pacific, southern part of the Pacific toward the Antarctica side, and Indian Ocean. And these are generally tropical cyclone used, regardless of the strength of the wind associated with their systems. These classifications, wind-based classifications, but this is a location-based nomenclatures given. And what makes a cyclone or hurricane or storm takes place? Pre-existing weather disturbance. There must be some pressure differences, high-level pressure differences, depressions, and warm tropical oceans are required, because without it is especially tropical and subtropical phenomenon. So big stretch of ocean is required, because this has to originate in ocean only, and sufficient moisture should be available. That is naturally part of the ocean, and relatively light winds should be there in the central part. Then the whole cloud can be moved by the wind. If the right condition prevails, then it can produce very violent winds and waves. Sometimes it turns into rain, sometimes floods. So there are different variations of that. And in cyclone, if you see that it has many components, the central part is called eye, because when this rotates, because when the wind flows from side toward the center, so there is a rotational effect. And due to the rotational effect, we'll find the central part will be more compensation. So this area becomes eye. That when the cyclone passes through the area, so the surroundings, periphery part, it will become more in the storms and rainfall, all of this increases. As it comes closer to the eye, it becomes almost constant, it doesn't increase. It becomes static, it becomes calm. Again, after the close to the eyes, again it starts increasing. Okay? So there is eye, you see different components of this is presented here. And now we'll see a small animation. How does this actually take place? You see, around the equator, it rotates faster compared to the poles. So because of that, so air and will be curved, water and air both, because air on the top and water on the bottom. Northern hemisphere, what happens? Air moving, so with Coriolis force, you can see air moving north, curves east, and this becomes the hurricane. Okay, so hurricane grows at the central regions with low air pressure, and this is how it looks from the top. Then it attracts the air pressure from outside, and it comes outside because Coriolis force will be counterclockwise in the northern hemisphere. And southern hemisphere is just the reverse, because of the Coriolis force we already discussed. And equator, what will happen? Usually you don't get any cyclone, any storms in the equatorial zones within 5 degree latitudes, because the cyclone never cross the equators. This is how they move. These are compensated zones, because strong wind it pushes the cyclone away from that. It doesn't allow the cyclone to come to the equatorial zones. Now I will see more details about how exactly the cyclone is taking place and how it looks.
Long, persistent, rotating updraft that is called a mesocyclone. That's a low pressure area. A mesocyclone is a low pressure area. Usually the storm is tilted off the vertical several degrees due to the vertical wind speed shear. Stronger winds aloft than they are in the lower levels. Here we see stratus forming and being pulled toward the storm. Now pressure is lower closer to the supercell, so the lowering pressure allows for the cooling of the air. So then the stratus becomes visible. Stratus is a visible representation of energy for the storm. On the right, the white-gray downward moving streaks are rain and hail. Inside the thunderstorm, many thousands of feet up, produce a large tornado and or smaller tornadoes, or one tornado, but more often than not, they will create damage with very large to huge hail and strong damaging straight-line winds. This is a terrific video of a storm creating its own miniature.
So you can see here how the tornado or cyclone or hurricane, how it starts, how it begins, how this axis is tilted, and how there are the different zones of ice frozen zones and the centralized zones where almost a clear sky, and how it keeps moving, how it's built up. So you have got some smaller conceptualization how it takes place. Now, based on the cyclone hurricane effects, you can divide this whole planet into 7 zones, 7 areas, okay, or 7 basins you can call, just like North Atlantic basin, ocean, the eastern northern parts of the northern Pacific Ocean, southwestern Pacific, southwestern and southeast Indian Oceans, North Indian Oceans, or Arabian Sea and Bay of Bengal, these are the zones. And there is subdivision of the zones in this picture it shows. And these are the areas where the maximum are, in fact, most of the cyclones do take place. Now, let's talk about some interesting concept about how we have already discussed about how the wind pattern of the planet takes place, but how the movement of the sea current takes place. Actually, in 1992, a cargo ship was carrying toys in Pacific Ocean and it got caught into the storm. And what happened? Because of that, the whole container sank. And since it is a toy, it has carried 28,000 rubber ducks, small ducks, and it all get released into the northern Pacific Ocean. And when the ducks are released, they are floated. Now, as they floated, you can see here, and they didn't stick together, they go in different places, and that is true all over the world. So how everything released at one place, they're distributing so many different places. This is what the researcher used to study the path of different ocean currents. So that means they all split at different ways, different locations. As you can see some of the pictures, how the journeys of the dogs has been found, different toy dogs in different locations, and how many are found. And that's how the different current and their speed and their movement are being tracked, studied by the scientists. So, ocean current are driven mostly by many parameters, the wind, the tide, the water density and rotation of the earth, all the parameters contributes to ocean current. And besides the topography of the ocean floor and the shoreline, they modify the motions, the planetary motions of the ocean, it will modify by suitably as per that. So there are two types of currents are there. Get two categories, are surface currents and the deep ocean currents. Surface currents control up to 10% of the ocean water, while the rest 90% of the ocean water was mobilized by the deep ocean current. However, these two currents interact with each other intricately to make the entire ocean moving. So the underlying or the boundary between these two keeps on moving upwards, downwards, depending upon the geographical location as well as depending upon the planetary temperature. So our different seasons and different circumstances, these do keep changing. Okay, and this line, which is called isohaline line, basically it's line of constant salinity. And so these lines keeps on varying, as I just now mentioned. So near the surface, the currents are mostly driven by wind and tide. Because this wind and tide try to drag these water layers which below that, and tide also because of sun and moon's gravitational attractions, it also makes the water to swell. So this is what creates the surface currents. So because of that, water back and forth moves, or rises and falls takes place. However, in open ocean, these two effects are not much. So what happens here? Only wind is the predominant, because tide doesn't make much difference. Only wind try to blow it, drag off for the surface water, which affect the lower water and further layer of water. And this way, water in the open ocean, open means far away from the coastal areas. So up to 400 meters of depth, water can be influenced by the wind on the top, which leads to surface currents. And what happens when these currents on the surface? So they forms a type of loop. When it goes there, then hits somewhere and comes back on the top. So they're called gyres. The gyres, which moves in clockwise in the northern hemisphere, anti-clockwise southern hemisphere. You all know because of Coriolis force. And as I discussed before, in relation to global wind movement, the same things will take place. The rotating gyres redistribute the heat on the equator all over the world, and more effectively than wind. Why? Because water has more specific heat than the air. So the temperature distribution can be done much more effectively with the water, and it is also continuous medium. Entire global water is connected to each other, so it will much more easily distribute the heat than the air, which has to go through the barriers of mountains and other things. Then we will now talk about deep ocean currents. So what happened? This current, it moves primarily by the change in density of the seawater. It has no effects on the tide, or for that matter, the wind density. So when water moves towards the North Pole, it gets cooler.